Hello and welcome. This video is going to be about proving lines to be parallel. If you remember the previous lesson, we talked about the different postulate and theorems that relates to parallel lines. So basically the condition is if we have parallel lines, which is denoted by these symbols right here, then we can conclude that the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, and the same side interior angles add up to 180. Okay, now today we're going to talk about the converse, which basically we switch the hypothesis with the conclusion. What do I mean by that? So right here, for example, this is a conditional statement. Anytime you have the word if and then, that's a conditional statement. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So in other words, what comes after the if is the hypothesis, and then what comes after then will be the conclusion. Now on a converse, basically what happened is the conclusion becomes the hypothesis and the hypothesis becomes the conclusion. So here's the example. If two lines are cut by a transversal so that the corresponding angles are congruent, then the two lines are parallel. So basically, if I have two lines cut by a transversal and I know that these two angles, which are corresponding angles, to be congruent, then I can conclude that line L is parallel to line M, and that will be the converse of the corresponding angle postulate. With the same idea, all the other theorems also applies. So here, if we have two parallel lines cut by transversal and the alternate interior angles are congruent, I can conclude these two lines to be parallel. Same thing with exterior angles. I can conclude that these two lines are parallel. And same thing with the same side interior angle. If they add up to 180, that means these two lines are parallel. So the basic difference is before we knew the lines were parallel, and therefore we could make the conclusions according to the theorems in the postulate. Now with the converse, we are given that the angles might be equal here. Okay, so we have a transversal and here we have these two angles that are equal. Therefore, I can conclude these two lines to be parallel. Here, these two angles are equal, parallel. These two are equal, parallel. And this one's with the same side interior angle, if they add up to 180, then I know the lines are parallel. So let's see some examples here. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justify your answer. So let's say I have this drawing right here, and let's say I have 1 is congruent to 6. Well, 1 and 6 is alternate exterior angles. So therefore, because they are equal, I can do the converse of alternate exterior angle theorem. And I can conclude that, if you notice right here, these are the two lines, L and N. So L is parallel to letter N. Okay, so then let me erase now, and let's do the next one. The next one says 2 and 3 are congruent. So 2 and 3. And this would be alternate interior angles. So it would be the converse of alternate interior angle theorem. And then it would be the line L and line M. Okay, let's try the next ones. Okay, so here we have a set of lines right here, and we're trying to determine which lines are parallel. Okay, so let's say I know the angle 2 is congruent to angle 8. So therefore, this would be my transversal. This would be alternate interior angles. So therefore, it will be line A and B. A is parallel to line B, and it would be the converse of alternate interior angle theorem. All right, let's erase that. And let's go on to the next one. 3 and 11. So here we're saying the 3 and 11. So if you notice right there, these would be corresponding angles. So be the converse of corresponding angle postulate. And according to this, these two lines would be parallel. So L is parallel to M. All right, the next set of angles would be 12 and 14. So 12 and 14. Again, here is my transversal. And since the problem is saying that 12 equals to congruent to 14, then I can conclude that these two lines, A and B, are parallel. And the relationship is the converse of alternate exterior angle theorem, because they're both on the outside of the line A and B. All right, let's go on to the next one. Next one, we have angle 1 is congruent to angle 15. Well, on this one, I don't have a transversal that touches both angles. So then we have a problem here because there's no relationship between these two angles. So then this one would be not possible or not applicable, okay? So in other words, you cannot do this one. All right, let's do the next one. 8 and 13. Here we have angle 8 and 13. They're on the same side of this transversal here. So that means there will be same side interior angle. So it'll be the converse of same side interior angle theorem. And because these are same side interior angle and they add up to 180, I know that these two lines, line L and line M, will be parallel. All right, the next set of problems is number 8 and 6. Okay, 8 and 6 are vertical angles. And so basically it's talking about this line and this line. So this one, I cannot use that information to show that any of these lines are parallel. So this would be not applicable as well, or not possible, okay? All right, let's go on to the next page. Here we are on the next page and we're given this drawing, okay? And if you notice, we don't know that any of these lines are parallel, but the problem is asking us, find the angle MRQ so that line A and line B are parallel. So we want these two lines to be parallel. So therefore, we look at these two angles here. These are alternate interior angle. So if I want these two lines to be parallel, these two angles must be congruent. So that would be 5x plus 7 equals 7x minus 21. And the reason why we are going to say that is because of the converse of alternate interior angle theorem. Okay, we're going to solve for x, so then we're going to do minus 7x. And we're going to subtract 7 from both sides. So this 7 goes away, this 7 goes away. On this side, I'm left with negative 2x, and on this side, I'm left with negative 28. We divide both sides by negative 2. X equals 14. Now, please be careful. The problem says find the angle MRQ so that A is parallel to B. So in other words, we're looking for MRQ. So basically this angle here. So the measure of angle MRQ will be 5x plus 7. I'm going to come over here and plug it in. And this would be 5 times 14 plus 7. And when we punch that in the calculator, five times 14 plus 7 we get 77. So therefore, the angle is 77. Okay, let's go on to the next problem. Next problem says, find the value of y so that E and F are parallel. So in this case right here, there's no relationship between these two angles right here, but I know that these are a linear pair, and if this is 90, this must be 90. Okay, so linear pair postulate right there. And now I can say these two are corresponding angles. So linear pair postulate plus the converse of corresponding angle postulate. Okay, so what's the property of corresponding angles? Is that they're going to be equal. So then I have angle 90 equals 4y plus 10. We're going to subtract 10 from both sides. So we're going to get 10 cancels. We're left with 4y equals 90 minus 10 is 80. We divide it by 4. Y equals 20. Okay, very good. And now this problem asks to find the value of y. So the value of y that makes these two lines parallel will be y equals 20. Okay, on the next problem, we are asked to complete the proof that if angle 1 is congruent to angle 2, then these two lines are parallel. And you might recognize this as one of the converse of the alternate exterior angle. So basically here in this proof, we're proving the theorem, the converse of alternate exterior angle theorem. So please remember that theorem is something that has been proven. So basically what we're going to do is we're going to prove that theorem. Okay, so this is going to be like a little introduction of, or a little taste of what proofs is all about. Okay, so right here is we're given that angle 1 is congruent to angle 2, and our goal is to prove that these two lines are the same. Okay, and so basically we start with the information that is given. Angle 1 is congruent to angle 2. That information is given. Then it says angle 2 is congruent to angle 3. Okay, angle 2 is congruent to angle 3, and we're going to use the vertical angle theorem. Okay, that's one of the laws that we have learned. Okay, and so now we have angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, and in geometry we have something called the transitive property that basically says if 1 equals 2 and 2 equals 3, then I can conclude that 1 and 3 is the same. Okay, so basically if I have 1 equals 2, so the first equals the second equals the third, then the first equals the third. Okay, and that's what is called transitive property. Okay, so basically I've shown that these two angles right now is 1 and 3 are congruent. Now remember, we can use postulate. Postulate is a line geometry that doesn't have to be proven. So of all the converse theorems and postulates, like remember we have CAEAT, we have converse of alternate interior angle theorem, we have the converse of same side interior angle theorem. These are all theorems, something that has to be proven, but the only one that does not have to be proven is the CCAP, which is a converse of corresponding angle postulate. So that means I can use that CCAP. That would be that angle L is parallel to angle M. So this is going to be just a little taste of what proofs is all about. So this concludes the lesson for today. So now you're going to be able to tackle the assignment, and I hope this lesson was helpful. Thank you very much for your time. Have a great day.